talk through them just now. Okay, for the first one, now guys, I want you to realize that there is a different question. All right, in the first question, the numbers don't have exponents, right? The numbers don't have like x's in the exponents. It's just a 2, that's just a 6, that's just a -2 that we're going to square. Right, so for this one, the x's have a lot of exponents stuff going. All right, so we have to multiply those exponents and add and subtract and so on. In the second question, in 1.6, this is not actually 27, right? It's a 27 to the power of x. So here, do we recognize the difference between the two questions? In this one, the numbers don't have variables in their exponents, so we can treat them just like normal numbers. We can multiply and divide them. Okay? In the second one, the exponents do have variables in them, so we can't actually just multiply and divide the bases I'm talking about. Okay, I can't say 27 times 9. Right, we're not allowed to do that because we have the variables in the exponent. Okay, so for this one, you would have to, because you're multiplying and dividing, you would have to write it in terms of the prime bases and then go from there. Okay, so I'll just give you some time just to mark those two properties. Then I'll tell you what you would mark for and just like that. And as the mark allocation is actually quite it's a bit strict in this case, in these types of questions, because for multiplying all of these exponents, you're going to get 1 mark. Right, which is unfortunate because if, say, for example, you got that one wrong, you will lose a mark for all of them. Okay, so that's important that you need to take care when you're doing this. So 2 times 4 is 8. 4 times 3 is 12. Here you need to square the -2 as well. All right, that's where that 4 is coming from. -2 times -2 is 4. And here 3 times 2 is 6. At the bottom, the 16 is not raised to the power of 5. All right, the 16 is 16. That 4 times 5 is 20. Okay. All of that, guys, is worth 1 mark. So to make one mistake, you lose that mark. Now, like I said before, because these numbers do not have variables in their exponents, you can just multiply and divide them. Like we normally would. 2 times 4 is 8. And then we have a 16 at the bottom. Right? If it was a 2 to the x, we wouldn't be allowed to do that. Right? Because there's no variable in the exponent, you can multiply and divide it. So that's what I did. I actually simplified the top. I said 2 times 4 is 8. And then I looked at all my x's. Then we have the same basis, so I'm going to just add those exponents together. Okay, so 8 plus 12 is 20 plus 6 is 26. And at the bottom, 16 next to the 20. That will give you a second mark for actually doing that multiplication. And then after that, guys, still, because the 8 and the 16 don't have variables in their exponents, I can actually divide them, right? 8 goes into itself once and into 16 twice. Okay, so there's going to be 1 on the top that you don't have to write, but there has to be a 2 at the bottom. Okay, when you are dividing and you have the same bases, same top exponent minus bottom exponent. So x to the 26 minus 23 is x to the 6. Guys, this last answer might be 1 mark, it might be 2. Okay, it depends. Sometimes they give 1 mark for the final answer, sometimes they give a mark for the numerator and a mark for the denominator. Right, but it might only be 1 mark for that. So guys, if this is a 3 mark question, that means you should spend maximum 3 minutes on it. Okay, just in terms of time. There were other ways in which you could have done that. Right, you could have done the 2 and the 16 right from the start, you could have cancelled that out. At this point, you could have started like cancelling out x's and stuff, or you didn't have to follow my steps exactly, but you do have to get to the final answer. If you're not sure if the steps are correct, ask me. I'll take it. Okay, 1.6. Now, because they are variables in exponents, like I said, we are not allowed to multiply and divide the numbers. So we have to apply the exponent rules. We know that the exponent rules, when we're multiplying and dividing, you have to have the same bases in order to use them. So to get the same bases, we have to write there in terms of their prime factors. Okay, the bottom one is already done. That's already a truth. But 27 to write as 3 cubed. And 9 you need to write as 3 squared. Okay, that will be one mark. Right, writing both of those. Then you need to again multiply your exponents. So 3 times x is 3x. I hope that you guys are remembering to multiply both. Right, the 2 must be multiplied by the x and by the 1. You get that. At the bottom it stays the same. As you get 1 mark for all of them multiplied half again. All right, just like in this question, all of them multiplying with the exponents. That is. Now from here, you're going to times and you're going to divide. Because if you have the same basis, your answer keeps that same base. Right? So remember that is how we do it. We can write one base of 3. We're going to add the exponents that you're multiplying. So 3x plus 2x plus 2. And then you minus the exponent that you're dividing by. Right? So you minus that whole thing in bracket. 5x plus 3. That is one mark. Laying that off. Then what I did here is I just actually added the 3x and the 2x together. That's where that 5x is coming from. Plus 2, and then I minus my negative, multiplied my negative 1 into that bracket. So negative 5x and negative 1 times positive 3 is negative 3. Okay, and then I just did that calculation. 5x minus 5x is 0, and 2 minus 3 is negative 1. But guys, you're not allowed to leave your answer with a negative exponent. You have to change it to 1 over 2. Okay. Now guys, technically, if you are not sure what this is, you can type it into the calculator. All right, I'm not going to know. I can print it out, and it will come up as a third. And unfortunately, that is the question. The question like this is only worth 4 marks, meaning that will take you maximum 4 minutes. Okay. Maybe you should write it just 5x, or at the top we can say 3 minutes, 4 minutes. Okay, when you're studying for your test on Monday, you can work through these specific questions again and time yourself and see if you can actually do it in that time. Any questions? All right, for 2.4, I did 2 different workings, 2 different methods. So you can take a look there. It's up to you what you want to do first. So what I did on the left-hand side here is I just raised everything in this bracket to the power of -2. All right, we know that if you have a fraction to the power of an exponent, everything in that fraction must be raised to that power. So I said -2 times -2 is +2. Then I say 5 times -2 is -10. At the bottom, this is just 3 to the 1, right? So 1 times -2 is -2. For this A, I have -1 times -2, that's +2. And then for the B, that's also just B to the 1. So 1 times -2 again is -2. Okay, so you can do that first if you want. I'll work through the right-hand side just now, but that's one option. Okay, if you have a whole fraction raised to a power, you can do each thing, each number and variable in that fraction separately. Then guys, remember when you practice negative exponents, I told you circle everything that has a negative exponent because that is what's going to use. Okay, so that's what I did next. The 2 to the 4, that is a positive exponent, so that stays at the top. The 3 to the -2 at the bottom has to move up. And remember, we times whatever we're moving up, we multiply by what was there before. Okay? So we times that by 3 squared. That one. And then at the bottom, we also had a b to the negative 2 that was moved up. And it becomes b to the positive 2. Then at the top, this a to the negative 10 does have to move. But guys, we already had an a squared at the bottom. Okay, we mustn't forget about that. So a squared is going to stay at the bottom. But then this a to the negative 10 has to move and it becomes positive 10. Okay, so this step was just me moving everything with negative exponents so that they can become positive. And then from there, I just multiply everything together. Okay, so now 2 to the 4 is 16, and 3 squared is 9, and you have a b squared, and at the bottom, a squared times a to the 10, we know that's a to the 12, right? Same basis, so we add in those exponents. And then all that's left, basically, because there's nothing that can cancel out now, right? And b's at the top, there are no b's at the bottom, there are no a's at the top, so I actually can't cancel anything off. But I do just have to work out 16 times out. Okay, so that's how you would do it if you first decided to get rid of these brackets, basically, by multiplying all the exponents. In terms of mark allocations, again, you'll get a mark for multiplying all of those exponents by negative 2. Then you'll get a mark for moving all of the negative exponents to make them positive. And the last mark, you probably get 2 marks for this last thing. You'll get a mark for the numerator and a mark for the denominator, because you actually have to do like multiplying and so. Okay, so also 4 mark question, guys, 4 minutes. Okay. On the other side, what I did here was I actually, remember, was it yesterday that we spoke about this, that if you have a negative exponent, you can swap the whole fraction and make that exponent positive. So that's what I did on this side, just to show you. So this whole fraction is raised to the power of negative 2. So if you want to make that negative 2 positive 2, you have to swap the whole fraction on the inside. Right, so you're not changing any exponents at first, you're just swapping the whole thing. Right, so the 3 a to the negative 1b goes to the top, and your 2 to the negative 2 a to the 5 goes to the bottom, and the negative 2 becomes positive 2 then. Okay, then I thought maybe some of you would prefer to actually simplify what's inside the fraction before you square it. You can do that as well. Right, so I decided to move this a to the negative 1 to the bottom. Make that negative exponent positive. And this 2 to the negative 2 I moved up. Make that exponent positive. It's still to the power of 2. And then I actually just worked this out before I squared it. So 3 times 2 squared is 3 times 4, that's 12. I have a b, and I have a to the 6 at the bottom. And then now I squared everything in the last thing. All right, so you can do that, guys. You can first simplify the whole fraction and then square it. Okay? So there you have 12 squared is 1.4. You have b squared and a to the 6 squared. 6 times 2 is 12. All right, or what you also could have done was you could have worked with this fraction, simplified it, and then raised everything to the power of negative 2 at the end. Okay, but then you would have to move stuff around again. So it is up to you guys, but whichever method you choose, this will be a good one. Okay, any questions on this one? All right, let's look at 2.5. There we go. Okay, so in 2.5, again, we had some negative exponents, but guys, you can't actually move this negative a to the negative 1 down before you square it. Okay, you have to square all of that first. So that's what I did. I got rid of the brackets. The 6 I kept it as it is. A to the negative 1 was now be times by 2. Negative 1 times 2 is negative 2. Right? Then you have b squared. At the bottom, the 4 is not raised to any power, it's just the 4, so I just rewrote it. And now this A and this B must be raised to the power of negative 2. So I got A to the negative 2 and B to the negative 2. Okay. Okay, if you're just looking at this fraction, you don't have to do it straight away, but do you see that 6 over 4 is actually 3 over 2? Right? 6 over 4 is 3 over 2, so I decided to simplify that. And then what's quite nice is that we have an A to the negative 2 at the top and the bottom. Right? If you have the exact same thing at the top and the bottom, you can cancel those off. Alright, you don't first have to move them and then cancel them off. Alright, does that make sense? Guys, an A to the negative 2 and A to the negative 2. You can cancel those off. I have a B squared at the top of this, B to the negative 2 at the bottom, because it has a negative exponent, it has to move up. And then I'm left with that 2 at the bottom as well. Alright, and then the last step was just to multiply B squared and B squared, which is root of it. Okay, so this would be a 3-mark question. Only you would get a mark for multiplying all of your exponents out, getting rid of those brackets basically. Then you would get a mark for moving the negative exponent to the top, and then you would get a mark for your final answer. This would have to be a 3-minute question. You have a little bit of leeway with the 50-mark paper, you get 55 minutes, but we all know that there's always some problem-solving stuff, some difficult questions that maybe will take a bit longer. All right, so for these questions that practice a lot, you need to try and keep to the time. Okay, guys, for 5.1, you have to solve for x there. Now, these equations are different from the ones that we did yesterday, or the day before. All right, the one that we did yesterday and the day before, it was an x with an exponent that was a fraction. Right? So there you raise both sides to the same power. Yeah, do we see that the variable is exponent? Right? Variable in exponent. Therefore, make bases the same. So we're going to work with prime bases, right? We are multiplying here. We can only apply the multiplication exponent law if we have the same bases. Right, so we do need to write that 16 as 2 to the 4 and this 4 as 2 squared. And now we have the same basis. We know that when we are multiplying the same basis, we add an exponent, so x minus 3 plus 4. And on this side, we have to multiply 2 by x, that exponent, so the exponent we must multiply. So I just put in an extra step. We didn't really have to show the step. I just actually added those together. Right, negative 3 plus 4 is 1. I just have to put that step in. Once you have the same basis on either side, you can then say that the exponents would have to be equal. All right, so x plus 1 would be equal to 2x. And then from there, you're going to solve that equation now. So you're going to move that 2x over. X minus 2x is negative x. And this plus 1, you're going to move over, it becomes negative 1. So x is going to be equal to 1. Any questions, guys? Now, this one, you would get a mark for writing the 16 and the 4 like that. Then you would get a mark for this line. So for adding these ones and for multiplying that, you would get 1 mark. You won't get a mark for this because it's basically the same thing, but I just added the minus 3 and the 4. You'll get a mark here for actually making the exponents equal, and then a mark for the answer. Right, so 4 marks, 4 minutes. Okay, the next one was a bit strange. All right, they now threw in a third in an exponential equation. You need to be able to deal with those. All right, we haven't done thirds as a specific topic, and thirds as a section is not in the test, but you do need to be able to go from third form to exponential. Right, like in this question. You did a whole note on. Okay, again, you have 5 and 12 sum equal to a value. Right, and we know that when your variable is in exponent, you have to make the bases the same. So now we need to try and write whatever they give us here with the base of 5. Okay, because here we have the base of 5, and we need to write this also with the base of 5. And guys, remember the rule for when you are going from surd form to exponential form. What is the exponent of 5 in this case? Inside the surd. The exponent of 5 is 1. Right? And what is the number on the outside of the surd? The square root. They're not going to write that number, but we must know that it's 2. Right? Then that rule is saying you're going to have the same base. The exponent inside the surd is the numerator, and the number on the outside of the surd is the denominator. Okay, so the square root of 5, you have to be able to do that, guys. You need to be able to write that as 5 to the power of a half. And when you type that into the calculator and you do the factor button, it's not going to come up as this. Okay, this one you have to be able to do on your own without using the calculator. The 125 you can type into the calculator and use the factor button. 125 is 5 cubed. But guys, I still can't solve this equation, right? I'm supposed to have 5 equal to 5. So what does I do now here? I'm dividing. What do I do with the exponents when I'm dividing? I subtract. So to get this with one base of 5, I'm going to have to say the top exponent minus the bottom exponent. For a half minus 3. Again, I just put in an extra step. You didn't have to. You could have done it here at the bottom, but I actually calculated that. A half minus 3. Again, you can use a calculator for that. That's fine. That's negative 5 over 2. So now we have the same bases, meaning that the exponents must be equal. All right, so 2x plus 1 has to be equal to negative 5 over 2. You have to move this plus 1 over, it will become minus 1. That's where I got that from. And then you must take this whole fraction and divide it by 2. Okay, so negative 7 over 2. Have it in the calculator, divided by 2 is negative 7 over 2. All right, so this would also be a 4-mark question, guys. You'll get 1 mark for writing both of these with the base of 5. You'll get a mark for doing this minusing, so for either one of these 2 lines. You'll get a mark for making your exponents equal, and then a mark for your final. Okay, any questions, guys? All right, we have one more type of exponential equation to do today. That will be in your test. And then we're done with all the content for the test. So you're reading. Sorry guys, I just had a full ground. Sorry. All right, guys, equations with different rational exponents. I'm going to show you now what that means. We've done equations with rational exponents, right? Where there's like an x to the power of the fraction equal to a number. Okay, so that's one rational exponent, one fraction. Now, sometimes you get equations, and here solve for x, where you get something like this, x to the power of half plus 3x to the power of a quarter minus 18 is equal to 0. So do you guys see what I mean by different rational exponents? I now have two exponents that are fractions, but they're actually different fractions. Right? So there's an exponent with a fraction of a half, but then there's also an exponent of a quarter. All right, so two different rational exponents. Okay, now guys, this is basically the most difficult type of exponential equation, right? So you might not fully understand it after the first example. We'll do a couple, all right? So just bear with me. What I want you to notice here is that this kind of looks like a trinomial, right? Do you remember what a trinomial looks like? You have an x squared, and you have a something x, and you have a constant term equal to 0, right? Now guys, when we have a trinomial, I'm just going to write one on the side here. Right, that's a trinomial, right? That's a quadratic equation. X squared plus 3x minus 18 is equal to 0. Now this x has an exponent of 1, even though it's not written, right? Do you agree with that? So what I want you to notice is that in a trinomial, if it's one that you can solve either with a quadratic formula or by factorizing, there will always be a 2-to-1 ratio in these exponents, right? The first term has an exponent of 2, the x, I mean. And then the second term, the x has an exponent of 1. This exponent is double the exponent of the middle term. Right, I'm going to write that down. Exponent of first term is double the exponent of the middle term. Circle the 2 and the 1 there, those are the exponents that I'm talking about. The exponent of the first term is double the exponent of the middle term. And then the last term is a constant. Okay, the last one doesn't have anything. Guys, if you're looking at the first equation, the one written in blue, the same thing is actually happening here. Not as easy to spot, but if we pay attention, then we can see, isn't a half double a quarter? Okay, a quarter plus a quarter will give you a half. All right, so in this case, we have the same kind of pattern. The exponent of the first term is double the exponent of the middle term, and then we have a constant term. So what we actually is, what if we want to do, but I'm going to show you quickly how to use the quadratic formula. Okay, right, so what we're going to do is we're actually going to solve this equation exactly the same way as we would have solved the one on the right. We're just going to write them out slightly differently. Let's quickly solve this equation together. Let's see if you can remember this. Remember, you need to be able to solve equations like this also in your piece. Okay? If it's a quadratic equation, yes. So let's do that. What am I going to write? X equals, yes. Let's quickly write down that formula for as well. Minus b plus or minus the square root of b squared minus 4ac over, what do we have in that denominator? Can you remember? 2a. Good. If we're looking at this equation, what is my a value? 1. Remember, a is the number in front of the first one, right? The coefficient of the first one. What's my b value? 3. And my c value is negative 18. Oops. 3. Down. Okay, so let's actually sub in those values now. Negative b is going to be negative 3 plus or minus the square root of b squared, so 3 squared minus 4 times a, which is 1, times c, which is negative 18. And that is all over 2a, 2 times 1. Remember, guys, you have to show that substitution step. Okay, if that step is not there, you're going to lose a mark. So then we'll type that into the calculator. And you will get 6 and negative 3. No, negative 6 and 3. Okay. Negative 6. 4. 3. That will be the other one. Guys, what I want you to notice, and we haven't really spoken about this before because it was kind of, just, it made sense if you did it in this way. But when you're using the quadratic formula, what we write here, you see that it's the same as the middle term. In the middle term, we have an x. So the quadratic formula is going to give us the value of x. Okay? Now, what is my middle term in this case? X to the quarter. Right? So now when we use the quadratic formula for this, which is what we're going to do, we're not going to write x equals, we're going to write x to the power of a quarter is equal to the whole quadratic formula. All right, so I'm just going to write here exponent of first term. And then in brackets, I'll just say I'm talking about a half. That's the exponent of the first term. Is double the exponent of the middle term. Which is a quarter. Therefore, we have the quadratic formula. Okay, so guys, whenever you are getting an equation like this, where you have multiple terms with different rational exponents, right? Different exponents, different fractions and exponents, you need to check. Whether the exponent of the first term is double the exponent of the second term, the middle term. If it is, you're going to use the quadratic formula. All right. Now, like I said, let's use a highlighter. what our x in the middle term is, that is going to tell us what we must write for the quadratic formula. We are going to write x to the power of a quarter is equal to the whole formula. All right, not x like we used to. X to the power of a quarter. Whatever you have in the middle term, that exponent is what you're going to write when you're using the quadratic formula. Your A value is still 1, B value is still 3, and your C value is still negative 18. Right? So we're actually going to have exactly the same substitute. Right, we're going to do negative B, B is 3, right? So we're going to have negative 3 plus or minus the square root of B squared. B is still 3, so 3 squared minus 4 times A, which is 1, times C, the constant term, which is still negative 18, over 2A, and A is still 1. So it's exactly the same substitution step as we had for the other one. The only difference is that now we're not getting x, we're getting x to the quarter. Right, but everything else is the same, guys. And then, just like you did, you're going to get 2 answers. Now again, guys, these answers are going to be x. What am I working out? X to the quarter. Right, so we're going to say that x to the power of a quarter is negative 6, or x to the power of a quarter is 3. Let's underline that again in the same highlighter. Right, all of that is coming from that middle term. Now guys, doesn't that look familiar? What do we do when we have an x with an exponent like that? We must raise both sides by, and we're swapping a fraction, hey? We must raise both sides to the same power. That will cancel out 1 over 4. Now guys, it's unfortunate that I wrote this one first. Let's just leave this one open. Let's do this one quickly because there is a complication on this side. Let's do the equal to 3 one first. Is my numerator even? No, so I don't have to do the plus minus. Okay, the numerator is 1. It's an odd number, so we don't have to do the plus minus. We're going to say x to the power of a quarter. Now, what do I get when I swap that fraction around? 4. 4 over 1, that's 4, yes, correct. Then I must do the same thing on the other side. 3 to the 4. Yeah, I'm going to get that the 4s are going to cancel out. I'm going to be left with x equal to 3 to the power of 4. You can type that into the calculator. That is 81. Now, guys, on this side, this is a little difficult to explain, and students usually have a difficult time understanding this. I'm first just going to say the rule and then I'll explain it. If the denominator, this is now an extra thing that you must remember. If the denominator of that fraction is an even number, right? And it's equal to a negative number, that actually can't happen. Right? So just circle that even. I'll explain why now. That denominator is an even number and you have a negative number on the other side, there is actually no solution for that. Okay, so just right here, no solution. I will explain why that is just now. I'm going to put in brackets in pink, even denominator and negative value. If you have that, then the answer for that will always be no. So guys, I suggest that you just kind of memorize that, like we've memorized now that if your numerator is even, you have to do a plus minus. Right? Now there's an extra thing that we must memorize. When the denominator is even and it's an even number, there's no solution. Okay. Now the reason for that, I'm going to draw a block around it and make an arrow. X to the power of a quarter, we can write that in third form, right? Can we do that? We remember how to write on exponent to third form. The numerator of the exponent becomes the exponent inside the third, and the denominator goes outside the third, so the fourth root. Right, so x to the power of a quarter actually means the fourth root of something. And guys, if I look at this equation, this is saying the fourth root of a number, and we must find out what that number is, we must find out what x is, must be equal to -6. Now, is that possible, guys? What number must x be for the fourth root of that number to be equal to a negative value? We think, what does it mean when we're finding the fourth root? We're looking for that, but if I multiply it by itself 4 times, right? So a number times a number times a number times a number, 4 of them multiply together. Is it then possible to get a negative answer if I multiply 4 of the same number together? Let's see, if I'm taking 2 times 2 times 2 times 2, what will that be? 2 times 2 is 4, times 2 is 8, times 2 is 16. Right? But if I do -2 times -2 times -2 times -2, that's also 4 of the same number that I'm multiplying together. Can that give me a negative answer? No, right? Will always be positive. So a negative times a negative is positive, and then that negative times negative is also positive. So that will also give me a positive value. So guys, if you're finding the fourth root of a number, there's no number that if you take the fourth root of it, it will give you a negative answer. Okay. Same thing will happen when you're looking for like the square root, for example. What's the square root of 9? 3. What's the square root of 16? 4. Square root of 64. 8. All right? Square roots, fourth roots, sixth roots, eighth roots, all even roots must always be positive. Okay, can never be negative. That is what this whole thing has to do. Okay, and what I need you to notice here now is the fourth root or the square root or the sixth root or whatever, that comes from the denominator. Right, because the denominator is the value that you put outside of that square. Okay, so that is why if you have an even denominator, then it actually can't be equal to a negative number. So then we have to say no solution. Okay, that's some complicated math that we did now, but I hope that that makes sense. All right. If it doesn't make sense, then I suggest that you just memorize this bit. Okay, even denominator equal to a negative number, no solution. Okay, it won't happen often. It will only happen in these types of questions. So guys, this was quite a hectic question altogether, all right? First, we have an equation that we have to recognize that is the trinomial. Okay, let's just go over that again. How do we recognize that? We have 3 terms, obviously. The exponent of the first term is double the exponent of the middle term, and then we have a constant term as well. Right? When you recognize that, then you can use the quadratic formula. Remembering that in your quadratic formula, you have to put the x that you have in your middle term. We're going to do another example now. Okay, without all of these extra notes. So you do x to the power of 4. If you start into your quadratic formula, you get your 2 answers. Then you have to do that whole thing of raising both sides to the same exponent. But we need to remember that if one of those values is a negative, that one will give us a notice. Okay, in terms of marks, you will get a mark for subbing into the quadratic formula. You will probably get a mark for each of these. You'll get a mark for your no solution. You'll get a mark for raising to both sides and for the final one. But this will be a simple question, guys, and it's a difficult one. Right, so we have to be aware of these and be able to recognize that type of equation. Right, if you don't recognize that that's a trinomial, you actually can't start. All right. It's not like notifications where you can move stuff around and get marks like that. Okay, you have to recognize that it's a trinomial before you can start turning marks. Okay, let's do another one. Yes. I don't actually am out. Oh, well, let's show it before. Okay. That is the next one. X to the power of 2 over 3 minus 7, x to the power of 1 over 3 plus 10 is equal to 0. Okay, obviously we have 3 terms. We notice that we have different fractions here in the exponent. So it's not one of those raise both sides to the same exponent, right? We can only do that if we have one fraction exponent. So now we check, is my first exponent double the second one? Is 2 over 3 double 1 over 3? Okay, if I say 1 over 3 times 2, what's that? This is 2 over 1. Hey, right, so I can say 1 times 2 is 2, and 3 times 1 is 3. Right, so this does work, right? This one is double that one. Okay, so this is a trinomial. Now we're going to say, remember, we're going to use the middle term x. So we're going to say x to the power of 1 over 3, not just x. Just write my a, b, and c value. We got a is 1. B is negative 7. Right? And c is 10. So we're going to do negative b, so negative plus or minus the square root of b squared minus 4 times a, which is 1, times c, which is 10. So the 2a, so 2 times 1. Type that into the calculator. I think it's going to be 5 and 2. X is a thank you. Okay, so x, the power of the third, is equal to 5, or x to the power of the third is equal to 2. Now, guys, in this case, we should look at the values that we have in those fractions now. All right, because we need to remember something. The numerator is even when we do a plus minus. If the denominator is even, then it can't be equal to a negative number. Is my numerator even? No. So I don't have to do a plus minus. Is the denominator even? 3? No. Okay, so if one of these two was a negative number, then you could actually work it out. All right, you wouldn't have to do it. Now, this was a negative 5, you could be able to solve that. Okay, this is that denominator is even. So this one is actually quite straightforward. We don't have to worry about that. What must I multiply a third by to get 1? 3. Good. We're going to do x to the power of the third to the power of 3 is equal to 5 to the 3. Yeah, 125, so the 3s are going to come out. So x is equal to 1, 2, 5. We're going to do the same thing on the other side, right? But have the same exponent. So on the other side, we're also going to raise both sides to 3. Threes are going to cancel out. So here x is equal to 8. Okay, I just want to I'll do some more complicated ones tomorrow. I just first want you guys to practice some of these on your own. So exercise 9. 13. Four. 7 and 8. And in each case, you're going to check if the exponent of the first term is double the exponent of the middle term. Then you use this method, right? You use the quadratic formula to get those two values. Then you must check, right? Keeping in mind what happens when the numerator is even, you must do a plus minus. When the denominator is even and it's equal to negative, then you say no to. Okay, all right. These 3 questions down for you. You can just start working on it immediately. Let's just quickly look at number 7, because it might seem a bit strange at first. What is the exponent of the x in my first term? 1. And the exponent of x in the second term is a half. It's 1 double a half. Okay, what's a half times 2? It is 1. Hey, so we have that happening in this one. Even though there isn't a fraction there, all right, we still have that the first exponent is double the second exponent. Okay. We need to check for that one. And number 8. Okay, let's quickly look at number 8. First exponent is -1. Second exponent is -1/2. Is -1 double -1/2? Okay, if you're not sure about that, guys, you can just do this. You can just check what's -1/2 times 2. It is -1. All right? So here we have the same thing happening. The first exponent is double the second exponent. The only thing that's different here is that when you're using your quadratic formula, you're going to write x to the -1/2. Okay, but that's not the end of the world. You can do that. So each time you're using your middle term to write when you are working with the quadratic formula. What do you also have to do in number 8, guys? Is it okay with that question on that side? You have to move it across. Okay, it's like a quadratic equation. You have to have everything zero, so that you can see what A, B, and C, what those values are. So this 20 must move to that side, then you can use the quadratic formula. Okay, you guys are staying here for the multi-purpose lesson, so you can just work on it for now. I'm going to have videos and stuff, so I'm going to take that off the screen. Just quickly stop recording.